Hi everyone, in this tutorial we are going to talk about how to convert a perspective drawing to a Newman projection. Okay, so it's really important that you consider the view from which you are looking about that carbon-carbon single bond. We could look from this direction or we could look from that direction, right? Okay, so the view is important and that will dictate what sides our groups are on and whether this first point on your Newman is going down or up. That's really important, okay? So it will look differently if we are perceiving this compound from a different viewpoint, all right? And I want you to be able to do this really effectively and quickly, okay? The first thing I want to note here is that about the carbon-carbon bond that we're looking down, the in the plane of the page bonds are a lightning bolt in shape. This indicates that we have a staggered conformation. It's the first thing that we notice. Let's talk first about this orange view, okay? We're looking on the page from left to right. We are looking from left to right. And when we do so, what's interesting here is on the front carbon, you can see literally just on the page, that bond to the in the plane of the page group, the benzene ring, is pointing down. That is why on the front carbon, the phenyl is pointing down, all right? And the in the plane of the page bonds, they will be in the middle of your Newman projection, okay? So we're going to say on the front carbon, you have a phenyl group, a benzene ring, we abbreviate that as pH, going down. And when you're looking from left to right, what I like to say is that the solid wedge is on the right. Okay, so it's in the direction that we're looking, left to right. The solid wedge groups on both carbons would be on the right side. So on the front carbon, the isopropyl is pointing kind of up and to the right here. And if the solid is on the right, that means the dash wedge is on the left. Your hydrogen is on the left of your Newman projection. Okay? Now, on the back carbon, the Cl is in the plane of the page. That will be in the middle. It's pointing up, right? Directionality is pointing up on the page. Therefore, it is up in the Newman projection. Again, we are looking from left to right, and therefore the solid wedge group, your CH2OH, is on the right side of your Newman projection. It's kind of pointing down and to the right. Okay? Now, your hydrogen, being dash wedge, will therefore be on the left side of your Newman projection. Okay? So we're going to reiterate that when you look from left to right, the solid wedge is on the right. I think that's a good way to remember that, and it's a 2D strategy for a 3D issue here, right? How do we convert a molecule and think in 3D space to visualize it differently as a Newman projection? Okay, the in the plane of the page bonds will be in the middle of your structure, and the solid and dash will be on the right and left, respectively. Now, if we were to look from view 2, we are going to see a different thing. Let's clean this up a little bit. If you're looking from view 2, now on the page we are looking from right to left, and the solid wedge is now going to be on the left. So the commonality is the solid is on whatever side of the Newman that we're looking towards. We are looking from right to left, solid is on the left. If we're looking from left to right, the solid is on the right. So now let's do view 2. Notice how on the front carbon, this guy right here, the chlorine is pointing up on the page, pointing up on the page. Therefore, in the Newman projection, it is pointing up. If we're looking from right to left, the solid wedge will be on the left side. Our CH2OH is on the left, which means that the hydrogen on that dash wedge is on the right side of the Newman projection. On the back carbon, the solid wedge isopropyl group will still be on the left side, and the hydrogen, which is dash wedge, will be on the right side. The phenyl, which is in the plane of the page and pointing down, is in the middle of the structure pointing down. Okay? This is going to take a little bit of time. Be patient with yourself. And remember, the directionality from which we're viewing the Newman is consequential to how we draw it. And also, you're considering that when you look at your Newman, at the front carbon, you ask yourself, where's the in the plane of the page bond? Is it up or down? From the orange view, view 1, it's pointing down. Therefore, that first radial spoke is going down, and accordingly, the other two are kind of going up. If on the back carbon the chlorine is going up, then the other radial spokes are going down and to the right, or down and to the left. all right? And again, those in the plane of the page bonds will be in the middle of your Newman projection. And in the directionality that we're looking, that is where the solid wedge will be. If we're looking from right to left, the solid is on the left. If we're looking from left to right, the solid wedge is on the right side of your Newman projection.